Hello students, I hope all of you are doing very well. So today I have concern related term 2 because some of students are going requesting me so I'm looking term 2 concept, some syllabus, some numerical which is based on this. So I'm considering this is a transistor. It's a very easy topic. First start to understand it's a easy topics, you can easily score very well because not even in term 2 it is also applicable for NEET as well as JEE. What student, it is also applicable for what NEET as well as JEE aspirants. Okay, so sir, why it is more beneficial? Because in these chapters you can put less effort and you will get good output, because one question is compulsory from what? Transistor. Yeah, but student, what this is a transistor, you can see transistor, it's a very easy topics. I have some tricks and tips. With the help of this, you can easily score number one question. Mean 1 mark. One question is what? 4 marks. 4 marks you can easily score with the what? With the chapter of transistor. So in transistor, basically I'll deal with what you can say. This is what? Common emitter. Student, this is common emitter, right? Common emitter. After that you can say this is a types of, you can say basically classification of transistor. Common base, and last one is common collector. This is what a student, common collector. Okay, common emitter, common base, common collector. Usually I'll just we people calling, I'll call as a what? Common emitter bole to CE. Common base, this is what? Basically CB. This is what? CV. And common collector, this is what? CC. This is not necessary to always call it's a long common emitter. You can CE, CB and CC, right? So this is a types of transistors, right? So just move ahead, take a screenshot student, and just I'll move ahead. Done? Okay, fine. So just move on. I'm going to tell what is the basics of formula. In these all what? You can say common emitter, common collector and common base, right? So first, this is the base. This is the trick. This is the base. You can easily score. Usually students are confused. What is the current gain? IB upon IC, IC upon IB. So no need to more confuse the student, right? I have some tips and trick. No need to remember. जैसे बोलते हैं रट जाओ, नो नीड टू ratification. You can easily understand how I'm generating the formula. If you will understand how I'm generating the formula, definitely you will secure single questions, and it's a very easy. It's easy to learn. So what is the what? You can say this is a common emitter. What's the name of circuit? This is common emitter. Okay, and next, this is common base, right? But student, next is what? Common collector. This is common collector. Okay, this is a circuit. Okay, fine. So what is the next? Next is what? You can always, this is the base, this is the trick to generate the formula. Input, you can apply base, and output collector, right? Input apply base, output collector in same. This is the process, this is the way you can apply in same. This is what? Input base, output collector, input base and output collector. Okay, this is the common scenario. These all applicables, right? Okay, fine. Next is what? You can see common collector. What is the common? Collector is common, right? So you can what? Easily add on common collector. This is what? Common, sorry student, this is emitter. So emitter is common, so you can add in output is emitter and input is emitter. This is common emitter. Okay, fine. Common base, right? The base you have already added. This is what? Base you have already added. Input base, output collector. So common base. Base is what? Common. So you can add what? Here output side base, and this is what? Ammeter. This is what? Basically emitter. Because on a same side, you can't add two types of transistor, like as a base, like emitter. No, you can't do that. Right? So this is basically configuration, common emitter, common base, and this is what? Common collector. What is the common? Collector is common. So you have already added collector in what? Output. So can't again add output as a collector. So we can put what? Ammeter. Right? And next is what? You can say this is collector, because collector is common. Just reminder one thing. So what is the common scenario? What is the common scenario? And this is the way at least one add on a single type. You can add collector as a, you can say this is common base. So you can add on what? Input as a base. So again you can't add base as a input. No, this is not done. Right? You can do one thing, definitely you can categorize base in input. So you want to again add base, so you can add in what? Output. Fine. So this is a basic scenario and configuration. This is the first agenda which we have already done. So what is the next? Current gain. So current gain, you can say basically you can thoroughly this is what? Alpha, and this is what? You can say common collector. This is a necessary condition to say one things. I am calling here, just say alpha, beta and gamma. Alpha, beta and gamma. Okay, usually you can say here current gain, but basically a formula, no need to learn alpha, beta and gamma. Right? You can learn formula. So what is the current gain? You can just add on current gain. Current gain. These all case. Right? Current gain in common emitter. Current gain in common base, and here current gain in common collector. So what is? Basically this is output current, student, output current upon input current. You can see what is output? Collector upon emitter. But this just reminder one thing. So what is common? Emitter is common, so can't you can take emitter, right? So this is what? Basically IC upon IB. IC upon what, student? This is what? IB. Got it now? Visible? Fine. Okay. So this is what? Current gain. And for what? Common base. Same formula you can say what? Output current upon what? Input current. So again I am repeating same word. This is base is what? Common. So you can't take base. You can't take base. So what is output? This is what you can say IC upon IE. IC upon what? IE. Right. Next is what? Current gain for common collector. Again, what is common? Collector is common. So you can't take output current as a collector. So what is the output current? This is IE. This is, student, basically IE upon IB. This is the common scenario. Usually students are more get confused. Sir, how can say if you can ask what is current gain in common emitter? IB upon IC. No, this is not a way. This is not a way. You can simply say what is the agenda. As I told you, student, this is a basic. This is a very common, and if you can gain to make the formula, definitely you can earn single question with the help of this video. It's a very easy chapters. It's not a chapter, it's a topic of the semiconductor, right? So this is what? Current gain for common emitter, common base and common collector. So again one most formula, that is what? Voltage gain. That is what? Voltage gain. So student, you can note it down. I don't have a sufficient space to write. Then take a screenshot this all formula, all erase and put the voltage gain for common emitter, for voltage gain for common base and voltage gain for common collector. Done? Take a screenshot, bacha. Okay, fine. Good. So this is what basically current gain. So I'm erasing. So current gain is what basically here IC upon what IB. So now I'm going to tell voltage gain. Voltage gain. So voltage gain is what? Basically you can say output voltage upon input voltage. Simple. This is what you can say, student. Output voltage upon input voltage. Output voltage upon input voltage. Okay, so output basically I'm going to tell some basics point which is related here. Ohm's law. This is basically Ohm's law. V is equals to I here. V is equals to I here. I'll use same result here, right? So output voltage upon input voltage. So what is the voltage gain for common ammeter? You can say this is, I hope you have already written. So this is output, you can say this I'm telling here output as a O symbol, I'm creating its on, and input it's I. Input it's what? I. So this is what? I naught upon into V naught. Input current into what? Input voltage. V is equals to IR. Sorry. So this is what? IR. R naught means output voltage. And this is what you can say input voltage. Simple. So I naught. What is the output in common ammeter? Na? Ammeter is not. As I told you earlier, right? So this is what you can say IC into R naught upon what is your base. Input current is base because emitter is common. No need to read ratification. No need to ratification. Try to understand what I'm trying to convey you. So this is what IB into R input. R input, RI means what? Resistance initial, resistance input. RO means what? Resistance output. So this is a voltage gain for what? Common ammeter. Voltage gain for what, student? For, you can say common. C in short form you can write CE. Got it? So this is the formula for what? Voltage gain for common ammeter. Take a screenshot, bacha. Okay, done. I'm giving 5 seconds. 1, 2, 3, 4, 5. Done. Good. So next is what? Voltage gain for basically common base. Voltage gain for student. This is common base. Again same formula you can use. Output voltage na. Output voltage means what is, again you can use a result. V is equals to IR. So what is output? This is base is common, so you can't take output current as a base. So what you will take? You will take IC, right? IC into what? R naught. V is equals to IR. Simple. I naught IC upon R naught. And what is the input current? Kya? Base? No. Why? Because base is common. So we'll take what? IE. I into what? R initial. Students, I hope are you enjoying now? Okay, fine. So this is a voltage gain formula for common base. Again I am repeating, this is output voltage, this is output current for common base, output resistance for common base. IE bole to this is what basically ammeter current for input in a common base, and R initial is what? Input resistance. Got it? Okay. So take a screenshot. Again 5 seconds. Okay, done? Done, student? Fine, good. So next, last one, voltage gain for common collector, right, student? Voltage gain for, you can say, common collector, CC. Same voltage output voltage upon what? input voltage. Fine. So output voltage means V is equals to IR. So what is the output current? No, you can't take IC. This is what IE, because the collector is common, right? So this is what you can say, student, IE into what? R naught. This is what? Output resistance upon IE. Next is what? Basically you can say, again, common is what? Collector. So can't take input current as a collector. You will take IB, right? This is IB into what? R initial means R input. Okay. So this is what? Basically voltage gain formula, which we have already calculated in what? Common ammeter, common base and common collector. So it's mandatory na, do some numerical which is based on this. Okay, fine. So let's start, student. Just take a screenshot, 5 seconds. 1, 2, 3, 4, 5, done. Fine. I hope you have taken a screenshot now. Fine. So just move on the next topic, which is based on some numerical on these all data, right? It's a very easy topic, students, so you can score very easily and very fantastic, right? Chalo. So I'm going to take some numerical which we can revise the formula, right? Chalo. It helps us to revise the formula. Just I'm taking here data, right? But in the examination, you will take a questions in the theory. After that, you can what? Just you can read the questions and take some questions data from out of the question. So you can say IB. This is what? Base current. Just say this is 50 microampere. Okay, IB, and this is say IC. This is just say 10 microampere. Okay, and already have given beta. This is what? Beta 100 or 100. Fine, it's a ratio, right? Alpha, beta, gamma. Usually अल्फा फॉर व्हाट, अगर जस्ट रिमाइंडर बच्चा अगर मैं आपको दूं तो अल्फा बेसिकली अपन करंट गेन यूज करते हैं किसके लिए, एक बार जस्ट रिमाइंडर, कॉमन बेस, एंड दिस इज फॉर बीटा फॉर कॉमन कलेक्टर, एंड दिस इज फॉर गामा कॉमन. देखो जस्ट रिमाइंडर अगेन, अल्फा यूजुअली दिस इज अ सिंबल विच ऑलरेडी गिवन इन द बुक्स. So alpha for common base current gain, alpha again repeating, alpha for common base, beta for common emitter, and gamma for what? Common collector. This is usually symbol which you can use, right? So beta what means current gain for what? Current gain for what? Common emitter, right student? So current gain for what? Basically for your information I am writing on the top of the board. Alpha bole to this is for common base, and beta for common collector, and gamma for you can say common base, common collector, and emitter and common collector. Fine. Okay, okay, fine. Okay student, so this is what basically you can say alpha, beta, gamma. So you have to find what? Calculate beta second. Okay, fine. So this is in what? Calculate emitter current. Calculate emitter current. Okay, fine. So how we can do that? Basically, you know, beta already given. So first you have to make what? Emitter transistor. Okay, so this is a way again you can revise your formula honestly, students. This is the common emitter. First you can add input as a base, output as a collector, right? And what is a common? Emitter is common, so you can add emitter in input as well as emitter in, you can say student, as output. So this is a beta, right? Beta means what? You can say IC, this is emitter, IC upon IB, IC upon IB. Okay, so what we'll do, that's already given IC and IB is given, so beta is not mandatory, so beta you can find out, right? Occasionally you can say you have to also find emitter current as well as current gain in common emitter, right? Current gain in common emitter. Okay, so beta you can easily find out. Beta is what? Basically IC means 10 microampere and IB is 50 microampere. This is cancel. So beta is what? Basically 1 upon 5. It's a unitless quantity because it's a ratio, right? So this is your formula beta. So how we can find out emitter current? It's a relation, student, you can use. This is the formula. So this is what we have done in step number 1. This is a mandatory to do the numerical step by step. Step number 1, beta IC upon IB. This is the formula. Beta is equals to 1 upon 5. So now how we can do that? We can say, student, alpha. Alpha you can find out. Alpha means what? You can say alpha common base. No need to find out common. We want to find emitter current na. So emitter current you can say IE. This is step number 2. IE is equals to IB plus IC. So what is IB? This is 50 microampere. IC, this is 10 microampere. So this is answer 60 microampere. So this is emitter current. Student, this is the emitter current. So this is what basically first question which is based on this. You can do easily. It's a very easy topic. It's a funny. So don't miss the video. Don't skip the video if you want to earn a single question, right? So you can put your efforts. Try to concentrate on the lectures. Definitely you'll do very best, right? So take a screenshot. I'll move ahead for our next questions. Done, students? Done? Fine. Good. So just move on the voltage gain, right? Again, just taking random data in the examinations. Just be careful. Occasionally, they'll give to you IB and IC are not a same unit, like as a milliampere and a microampere. So we concentrate how to convert these all data. So now I'm going to take what? Find voltage gain. This is a basically questions. Find voltage gain. Find voltage gain. Right, students? So this is what basically find voltage gain. Fine. Just say I'm going to take voltage gain for what? Voltage gain for common emitter C. Just note one thing, student. What is the note to everyone? Note is what? If nothing mentions in your questions common base, common emitter, common collector, in that case you can consider common emitter because it's a more efficient, it's a efficiency based these all circuit, right? So just reminder, you can solving questions, right? Or if you are solving the questions, definitely in this case you can consider what common emitter as a what? It's a efficient transistor, right? So here mention key voltage gain for what? Common emitter. Okay, so I'm going to take R naught some data. This is output current. Just I'm going to tell this is 10 ohm. This is 10 ohm. और data like kilo ampere, kilo ohm कुछ ऐसा. Kilo ohm. Ohm is a what? Resistance unit of ohm. Next input. This is I can say 5 kilo ohm. 5 kilo ohm. And voltage gain basically you want to find IC and IB. So you can say IC. I'm going to tell just change here. Just 5 milliampere IC and IB basically 20 microampere. Right, student, I have changed now. here is 5 only, and here is what, 20. Here is milli and here is micro. So this is your choice, right? Or you can do milli, you can convert 5 into 10 to the power minus 3 ampere, or you can say 5 in this is 20 into 10 to the power minus 6 ampere. This is your choice, right? So basically you want to find voltage gain. So no need to, again I'm repeating now, no need to learn the formula. You can draw easily. Voltage gain means just make a circuit. Just make a circuit, right? This is what common ammeter. Input, you can put the base, output as a collector. Ammeter is what common. Students, just look at now. I'm not remember any formula. Just know what is the process. So output as a IC upon what, IE, right? Because base is what common. No, sorry sir, आपने गलती कर दिया, right? This is not a way. क्यों? Because IC upon IB, because ammeter is common. अभी आपने मुझे बताया, right? So this is what you can say beta current gain. This is IC upon IB. Fine. So this is IC into R naught upon IB into R input. So what is IC? IC 5 into 10 to the power minus 3, student. Next is what? R naught is 10. R naught is 10, not 4. 10 kilo ohm. And next IB 20 into 10 to the power minus 6. 20 into 10 to the power minus 6. And you can say R1 5 kilo ohm. Again unit place cancel, right? So students just do solve. 5 cancel, 10 2 ja 20, right? So now I'm going to erase this formula and I'll write, take a screenshot. The student take a screenshot first, then I'll erase the formula, right? So what is your final scenario? This is 1 upon 2 10 to the power minus 3 into 10 to the power minus 6. Just you can know, student, ki this if numerator goes on denominator, so this will become positive. So this is what 10 to the power q upon 2. So just I'm going to write 10 into 10 ka square upon 2. 2 5s are 10. So what is your final answer? 5 into 10 to the power 2, or you can say 500. It's a voltage gain, right? So done. Student, this is the today lecture which is based on transistor. I hope all of you enjoy. Just comment, press the bell icon, subscribe my channel. You will get a latest update in every day. I'm trying to help everyone because JEE means registration process is going on, and all of you are excited to learn new things. So you can take a screenshot. Every day I'll just make a new video which is relevant to your topics, your syllabus. So subscribe my channels, press the bell icon. You understood the lecture or not? Just comment in the comment section. Bye bye students.